So, we're looking at our reverse chain rule. We got to find the big guy, the little guy, and then we got to set up the derivative of the little guy. Remember, the big guy needs to be something that you know how to integrate, and then you got to be able to match up the derivative of the little guy. So, for example, I couldn't do cosecant as the big guy. Be able to learn how to integrate that. And even if we did, that would make 5x to the third plus 3 the little guy, and then the derivative of that doesn't have a cotant in it, so it doesn't match. But if you make the cosecant cotangent the little guy, or the big guy, that makes 5x to the third plus 3 the little guy. And then little guy prime is supposed to be out here. So what is the derivative of 5x to the third plus 3? 15x squared. So I need to turn this into a 15x squared. So I need to multiply it by negative 1/3, because then it makes it 15x squared. It'll cancel. Well, if I put a negative 1/3 on the inside, I need a negative 3 on the outside. Right, you with me? And then I integrate the big guy. So what's the integral of a positive cosecant cotangent? A negative cosecant. There's already a negative out there, so now it's positive. Then you leave the little guy alone. And don't forget plus c. Does that help? It's hard. I feel weird going over these because it's just like one step. And I'm like, there you go. But so stop me if you're. Where'd you get this? Where did this come from? How did this happen? Whatever. Any other ones? What other ones? Please, other ones. It's good for you guys to just see a couple to kind of get your brains back thinking about what we're doing. 6. Did you just say one because you thought I wanted one?
Maybe. I cannot confirm or deny.
That's fine. If there's no questions, I would just give you a couple of things just to talk about. Like, just to. The research says that if you see something, curious what you guys think. If I was going to give you 30 minutes of instruction on something, would you rather have it all at once or like 3 10-minute chunks? Like 10 minutes one day, 10 minutes next day, 10 minutes next day.
It depends on the topic, I think.
Yeah, that's fair. But the research says like you're supposed to split it up and do like a little bit every day. So
I mean,
that's why I do like warm-ups.
I can see where that comes from, but I think it depends on the complexity of the topic. I think if it's something really complex, then you want to split it up into 3 days so you're not overloading us with information.
That's like
However, if it's something simpler concept that should be easy to understand, try doing it all at once, and then if we need more, spread it out over another couple days.
Alright, so what's the big guy here? Big guy's cos. The little guy is 4x squared minus 5. So little guy prime is supposed to be 8x, but that's not 8x. This is actually the same adjustment as the last one. So I need, what do I multiply this by to turn it into 8x? Negative 1/3, and then that makes that 8x, which allows it to disappear. Then I put a negative 3 out here. And then what's the integral of a positive cosine? A positive sign. Leave little guy alone, and then plus c.
Oh, it's if it's
The derivative of cosine is negative sine. The integral is positive sine.
it throws me off because I know it's cosine, but I always forget its integral of sine is negative cos, and that's
Yeah. So this is similar to that first one we did. Your big guy is going to be the cosecant cotangent. Your little guy is the x squared plus 4. It's just written in 2 spots. And the little guy prime is 2x. So I need this out here to be a 2x. So what do I multiply negative 8x by and turn it into 2x? Negative 1/4, right? Which then makes that 2x, which then allows it to disappear. I need the -4 on the outside. And then my job is to integrate the big guy. So the integral of cosecant cotangent is negative cosecant. But there's a negative out there also, so now it's just positive cosecant. Leave the little guy alone. And plus c. Did you just say something so I can do something?
No, actually, I did actually focus on that one. I just forgot to cancel the little guy prime.
Gotcha.
I got all of the rest of them correct, and I missed the rest of them. I don't know what it was about this one where I forgot to do that stuff.
So now you guys are just humoring me, just saying, here, do this if you feel like you learned it. Alright, let's get your notes out. You already talked about that. Now you're just whining.
I might less.
I am whining. You're right.
I
am whining.
might less correct. Keyword whining.
I always whining.
I get 0 pairs.
Not so much. But it was either immediately after break or fairly soon after.
Write that down. Do you want a title?
Yes.
You guys like titles?
I do.
So last time we did the reverse chain rule with all the trig. We kind of mixed in a couple of e's. I just gave you a few examples with them, but now we're going to do e's and x to the -1. The e's are the easier one. X to the -1 can throw you off a little bit. So what I did was I printed your worksheet, and I just hit modify questions, so it gave me like a whole new worksheet with the same questions, and we'll just go through a few of those. Make sure we hit like different kinds. These are tough for me to just like right on the spot. So first thing I do is rewrite this so it's not a fraction. I'm going to bring everything up. So I would make this, I would treat these two separately and say, okay, that's 1 over x, and it's also 1 over that stuff. So I'm going to write it as x to the -1 times -5 plus ln of -3x to the -1. Do you see what I'm doing to get to that? So I'm bringing the x up, that makes it x to the -1. I'm bringing this chunk up also, which makes it that to the -1. And you'll see why in a second, hopefully, that I want them separate. So what's the big guy? This is actually going to be your little guy.
No,
This
I'm saying that chunk because the -1 is the -1 is in 2 different spots. So
Gotcha. Okay, so you're clear. So that's your big guy.
Yeah.
You were just trying to clarify which one. So this is your big guy. That makes this your little guy. And then, so here. I'm writing it again just for some reason. I think it, like as these get more complicated, I think this is really helpful. Where you write down like L equals this, the little guy equals this, and then L prime. So if I started from here and I ask you to take the derivative, what is L prime? And then we'll see if we can match that up with like the part we haven't used yet. So what's the derivative of -5? 0. And then what's the derivative of ln of something? 1 over the thing. So this would be 1 over -3x times what? Times -3, because you got like a chain rule in there also. So when I multiply those together, you just end up with 1 over x, or x to the -1 if you want to call it that. So this actually is little guy prime right now. I don't have to adjust it. The super common mistake here is you'll forget this -3, because it's hard to remember that like chain rule part in there. And then you'll end up with like a -1/3 x to the -1, and you'll start trying to adjust things, but you really don't need to. And here's the nice thing about that. I don't care what number is there. Let's just call it a. If I take the derivative of ln of a times x, So we'll call it any number you want. Wouldn't it be 1 over ax times a? So what am I going to end up with? 1 over x. So I don't care what number is there. The derivative of ln of ax is just 1 over x, because those, whatever the number is going to be on the top and the bottom. It'll just cancel. But it's really easy to forget that. But anyway. Now my job is to integrate the big guy. So your standard thought process here is I'm going to add 1 to the power. But what does that give me? 0, which isn't necessarily a problem yet. But my next step is to multiply by the reciprocal. What's the reciprocal of 0? So I'm going to multiply by undefined? Like, that doesn't make any sense. So that technique doesn't work when your power is a negative 1. And that, like, thinking through that hopefully helps you remember why. So, okay, add 1 to the power is 0, multiply by the reciprocal of 0. Well, I'm stuck. That doesn't work. How do you integrate x to the negative 1? Everyone got it right on there. But most of you got it right on the memorization quiz. Natural log of the absolute value of x. So, little guy prime is going to disappear. And the way you integrate a negative 1 power is the natural log of the absolute value of what was in there. And then plus c. So remember, the integral of x to the negative 1 is the natural log of the absolute value of x. Plus c, I'm just doing that with a bigger chunk on the inside, basically. Questions anywhere? Can I go ahead, or is everybody still writing this? Okay. Let's see what we got next. Let's try that. They don't put parentheses in these spots. I think you guys are used to seeing it, but there's technically parentheses there and there. You can't have like cotan minus 2x, because cotan needs something to go with it, so it's cotan of negative 2x, cosecant squared of negative 2x. So if I were to rewrite this, I have negative 8 cosecant squared of negative 2x times cotan of negative 2x, so the negative first, and then times dx. So, what's the big guy? Negative 1, right? Can you guys see that that's the big guy? Like, does that make sense to you? It's possible it could be this 2 or this cosecant squared, but if you like thought through the big and little guy, it just doesn't match up. But I could see why you'd think that, but it wouldn't fit all the pieces correctly if you used it that way. So this is our big guy. That makes this our little guy. So the little guy is cotan of negative 2x. So, find little guy prime. Let's see if we have it or if we can adjust to get to it. Again, this is why this thing just has to be memorized. Like if you don't have the integrals and derivatives memorized, you're just stuck. So what's the derivative of cotan? Negative cosecant squared, leave little guy alone, and then times negative 2, right? So that's kind of easy to forget. So what you basically have is positive 2 cosecant squared of negative 2x. And this kind of is a cheat for you almost. Like if you forget the derivative of cotan, there's a pretty good chance it's sitting right in front of you and you just got to remember to look there. But I don't have 2 times all that stuff. I have negative 8, so I'm going to have to multiply this by negative 1/4, and then that'll create 2 cosecant squared of negative 2x, which is what I want. That allows all of that to disappear, and then you put the negative 4 on the outside. So all the work I've done so far is just getting it set up so little guy prime is there, so that it will disappear, so I know what number to put out here. Questions on that part? So my next job is to integrate the big guy. So if big guy's a power, I'm going to add 1, that's 0, multiplied by the reciprocal. Oh crap, that doesn't work, so I'm stuck. So what do I use instead? Natural log. I mean, like, I've been teaching this for 20 years now, and that's literally still my thought process. Negative 1 power, I'm just like, oh, it's a power, add 1. Oh crap, oh yeah, natural log. Like, I still have to, I still go down that road for a second until I get stuck. So, natural log of, and then you put absolute value, because you can't take the natural log of a negative number, plus c, and you drop down the negative 4 from there. It's good that you get stuck when you try to do the power rule, because otherwise you might, I don't know how that would happen, but you might try to do it. Everybody have that before I got to it? Like, I don't know if people are working ahead before. Okay. Questions on it? Try that. I'm not going to talk. You talk. You do it. At least there's no cosecants and trig and all that stuff. Well, in this one. Yeah. Everyone did.
Not you specifically.
Alright. So, 4x to the 4th, 2x to the 5th minus 5 to the negative 1st, times dx. So the little guy's 2x to the 5th minus 5, so what's the derivative of that? 10x to the 4th. And like, you can write the L and L prime. I don't know if you need to on something that's like, this is a little simpler, you know? It's not going to hurt you to write down, okay, that means L prime needs to be 10x to the 4th. So that means I need a 1/4 here, 4 out there. That goes away. 4 drops. I integrate the big guy, add 1 to the power, I get 0, multiply by the reciprocal. Oh crap, that doesn't work. Oh right, that's LX. How many had that answer? Question that. I had something different. Where'd you get this? So this is supposed to have E's on it too. There should be some coming somewhere. There. Yeah, that's good. We can do that. Try that. So this will be your big, this will be your little. The derivative of e to the 5x minus 2 would be e to the 5x times 5, right? Because you got the chain rule part where you multiply by the derivative of the top. You have e to the 5x times negative 25. So you got to multiply your inside by negative 1/5, which then makes it 5x e to the 5th, which then allows it to disappear, which then makes you put a negative 5 on the outside. So far, so good? So then I integrate the big guy, add 1 to the power. Oh crap, that's not going to work. That's natural log. And then bring down this number, and don't forget your plus c. How many of that? Good. Questions? Yeah.
Why doesn't the game cancel? Because the natural log of is just 1. Why isn't it the natural log of x is 5x minus 2?
Oh, so we could simplify it. We could break it down and say like that's negative 5 times the ln of e to the 5x. Subtraction, and it's a little different with logs because you're working with powers now. So subtraction relates to division because you subtract powers and you divide. So we could like break it down some more, but we don't have to.
So it doesn't just like easily simplify.
No, well the ln will have to apply to the 2 also. So like you're actually like when you unpack it, it's making it like more complicated. So you're unsimplifying it to do that. Where this is the simplified version.
Okay.
You alright? Okay. Alright, I want you to try this one. I'm not gonna say anything. I want to see if you can try if you can do that. That's not one of the things I made you memorize. At least not yet. Now I'm going to, but try to figure out that problem. Then I'll go through it. Then I'll put it on the board. That'll be added to your list of things you have to memorize. But to be honest, I don't memorize this one. Like I can't tell you right now what it is. I have to like work it out, which is a reasonable thing. Also, you can either remember it or you can remember the process and just kind of get to it whenever you need it. First hint is what does tan mean? Sine over cosine. Start there. So then I would bring the cosine up. And like think about what we've just been doing and see if you can get it from there. So what's the big guy? This negative 1. That makes this the little guy, so the derivative of this should be out here. What's the derivative of cos? Negative sign, so you got to put a negative here and then balance it with a negative there. That is then going to disappear. The integral of negative 1 is natural log of the absolute value. Drop down the negative. That is something you need to know. So this, if I give you a memorization quiz, which I'll usually give you a warning, you know, that is fair game now. Yeah.
Why is it negative on the positive?
Because the derivative of cos is negative sign, so I had to put a negative there to create, you know what I mean?
I
Right. That's the hard part is keeping track of which is which. So this is fair game now. And when you get your memorization quiz, like I just told you, I didn't have this in my brain. The rest of them I just know, like I have it memorized. If you give me tan, I have to kind of think through this process and be like, okay, bring the cosine up, negative, work it that way. And that's fine. Your job is just to know that integral. If you can know it by memorizing it, great. If you can know it by like working through it when you get it, that works too. So what's the next problem I'm putting up? So integrate cotan. Very similar, it's not exactly the same. This right there, you probably guess what the answer is. So that's cosine over sine, right? Which would be cosine of sine to the negative first. And then you're just playing with your positives and negatives. This one comes out where it doesn't have to be negative at the end. Because such a big guy, what's the derivative of positive sine? A is positive cos, so we're all set. We don't have to adjust anything. So it's just the natural log of sine of x plus c. So that's another one. Add this to your list of things that you have to know. And again, I don't care if you memorize it or just work it out really quickly when you get the test, but you got to be able to give me that answer if I ask that question. Fair enough? Alright, let me give you the worksheet, get you guys working on your own stuff. And these, I fully expect these to be tougher. So I hope that when you come in tomorrow, you'll have a bunch of questions. Sammy, you gonna be here? Alright. Yeah, so if you have flashcards, I know a lot of you have flashcards. Put those two on there right now. Everybody get one? Actually, come right there. Yeah. That's awesome. Color coded based on what?